Welcome back to Educator.com, Intermediate C++. Today we're going to look at some real actual code that needs to be put together and actually run an application. If you've taken the introduction class and you've seen that we've had a little program for making a checkbook account, which we've kind of expanded on a little bit, and we made it a little more object-oriented using some of the new features that we should have learned in the intermediate class. So let's take a look at some code here. What we've got here is a MacBook, which runs in a Unix-like environment. So these are the files that have been developed so far. The CPP files are C++. The header files, each one has a corresponding header file. So as you can see, we've got the account and date field exception. So let's take a quick look at the global constants. So we see we've got our include guards there. We have global constants defined. So if the global constants is not defined, then we define them. So we can include the global constants in each C++ file. So even or in each header file for each object. So if an object gets included more than once, or if an object includes another object, these constants will be included and defined exactly once. So we've got a version here set to 0.2. This screen overlapped, and that's okay, or wraps rather. And we have an ini file that we're going to use the same as the previous class, which is probably the worst name in the world that we can use for that, but that's all right. We're not going to worry about that. So next thing I want to take a quick look at, let's look at the account object. I'm not going to be looking at this in any particular order. I just want to try and cover as much of this as we can in the time constraints. So there's a little quick header block. Now we're including the header file. The CPP for an object needs to include its own header file. As a matter of fact, thinking about it, we should look at the header file first, shouldn't we? All right, so there's our include guards. Now we're using vector, we're using set, we're including string field, number field, integer field, and transaction objects. So here's our definition. We have the account includes a, here we are. This is our callback function. So when the caller calls our function, we want their function so that we can call them back. So the way this is being used is to make sure that when we make a new account, this account is unique. And so we want the caller to keep track of how many of us there are and what our names are. So if the user puts in one that we've already got, then we will get a function back that says is unique will be false, because that means we've got a duplicate name here, so we can do something about that. So here we have a vector. Now, like I say, if you took the introduction class, you notice the transaction was an array, and we had a predefined set of like 5,000. You can have as many as 5,000 transactions. If you had 5,001, you had to send the company money to get an upgrade. Well, here is the upgrade where we're using a vector of transactions. So we can put in as many transactions as will fit into memory. And the other ones, we have an account ID, the file name where we're going to store this account, and then for each account we'll have its name, city, account number, description, transaction count, the next transaction ID. So each transaction gets a unique ID, and we'll increment the next trans ID for that, and the check number. Not every transaction will have a check, because sometimes the transaction's a deposit. Sometimes you just go into the bank and say, I just want to withdraw $100 so I can go down to the casino and lose it, and whatever else you're going to do. So you won't have a check number. But when you do have a check number, you want to keep track of it. So we'll keep track of it right here. And each time we use the check number, we'll increment it. And again, the user will be able to override the check number, because sometimes they want to write the same number again, or the number gets too large. They want to start back over at 1001. So the user has complete control over that. But we'll always give them, this is what your next check number is. You know, it drives accountants crazy when the check numbers aren't in sequence. But we have to allow for the fact that users will drive accountants crazy. So here's our constructor. We have our default constructor. We have our copy constructor, so we can copy an account to another. And here's where we're creating one with a new file name. So we can check, so is this file name unique? If it is, we'll just proceed. If it's not, we'll do something else. Here's where we're constructing it with the is unique function. So we will attempt to create it, and if it's not unique, we will back out of our creation. And here's our destructor and the method startup. So when we make a new account and everything's all right, all the rules are satisfied, we'll call startup to start up. And that should be the end. Yeah, that's the end of this file. So now going back to, let me see if this works. Oh, that works, good. So here's our copy constructor. So the account ID is set to the account ID, the file name gets a new file name, etc., etc. All that's pretty straightforward. Here is a vector copy where we take our transactions, See, here's our transactions, the empty, the default constructor, we just make it the empty transactions. And here we're copying, using the assign method to copy the iterators from the begin of the new account transactions to the end. Here we are. So what we're doing is we're taking in this copy that we're doing, we're getting a new account that's being copied to, actually this should have said old account, shouldn't it? Well, I'm not going to change it now. So we're copying from the previous account to a new account, and this is how it's done with the vector. Now this is where we're using a string field if we're having a new file name. This is where we call it, it's not a copy constructor. All we're doing is starting up and we're getting our callback function and then saving it so that we can use it later. And we don't have anything to destroy, so the destructor is empty. And here's our startup, which just prints out that we're testing. Because there's a lot more work to be done in this, which is why you're going to have homework assignments. So let's take a look at the user. There's our include guards. We're keeping things in files. We have a file stream, our string, our vector. We have number fields and string fields. And the user owns accounts, or the relationship is user has an account. So here's our vector. So the intro class, we just had one account for one user. In this one, the user has some number of accounts. We don't know how many he's going to have, so we'll store them in memory in a vector. And each user, well, our first thing we need to know the version of the software. It's the same thing we did in the intro class. We had the version was 0.1, this one's 0.2. And we assign a user ID, which is not implemented at this time. And of course we have a name, the address, city, state, zip, telephone, a bank code, and then a file name where we will store the user information, including his IDs, name, address, and the number of banks that he has. Actually, bank code is just left over from the intro class. We should just take that out. Let's see if it's used anywhere else in here. This, by the way, is Vim editor. No, it's not used. The next thing is to check see if it's in the CPP, which we'll check in a minute. So here's our constructor. Here's our copy constructor, our destructor, our startup, where we have a version and the ini file, which will store the data about the data. Here's where we're going to create a new ini file, brand new program. The person just bought the package, just installed it on his machine, started running. We're going to run. We're going to say there's no ini file. Now, more sophisticated PC applications will keep this type of information in a registry, which is way beyond the scope of this class. So we're just going to have an ini file to store information like where all the other files are located, that sort of thing. So we're going to read the file. We're going to set our version number, get the version number. And then our private stuff is to check the validity of a bank code that gets entered to make sure there's no spaces or hyphens or other nasty things. And if we check the file and it's not there, we want to be able to write it. So there's our two private methods. Okay, let's search for that bank code. I bet you it's not needed. Well, it's in the copy constructor, of course. And that's the only place I'm going to get rid of it. Let's go back to the previous one. Software is never finished. So we'll take a quick look through here. Our default constructor doesn't do anything, but our startup has our setting the version. And here's our try. We'll open the file and close it. That's all we're going to do, see if it exists. If it doesn't exist, we'll get an exception. And we're using the C-style error nodes because they're a little more useful. So if it's equal to 2, that means it's not there. We'll just create another one. If it's not 2, that means there's some other problem, such as you may not have permission to that directory. The directory may not exist. You might be trying to write out to a thumb drive, for example, and somebody pulled the thumb drive out, and so the whole disk is missing, and so you get some type of error, and there's no sense in proceeding if you get that type of error. And so what we'll do is if we get a 2 error node, that just means it's not there, no big deal. We'll call this method, create a new ini file. But if it's not 2, then we'll print to the user, I got a problem. What am I going to do? And we'll print out what the error node, which might give them some information. Your typical user is not going to know what to do with that. But he'll call up customer support and it says, error node number 13, what do I do? And then your person answering the phone should know what error number 2 means or number 13 or number whatever. So we're printing out oops, we're printing out the string message from our exception. And then we're throwing a serious exception that will go to whoever called our user object. And I'll show you the exceptions in a minute. And so here we're just actually, if all of this works out and there's no exception, there is an ini file, it should be good, we'll read the ini file. And reading the ini file should be in here someplace. There's our copy constructor. There's our empty destructor. Here's where we're creating. I really want to see read first. And here's reading. And we're setting up an input stream and turning on the exception fail bits. So if something goes wrong, normally you just, you can test the bits after you perform an operation, or you can turn on the exception. So if something goes wrong, an exception will be thrown. So you don't have to do operation test a bit, do an operation test a bit, do an operation test a bit. You just do the operation, and the OS or the C++ libraries will do the testing for you. If something goes wrong, they'll throw an exception. So we'll just put that inside of a try block. So what we're doing is opening the file. We're grabbing the check version, and we're defining these. So number field is an object that we define. We'll take a look at that later. And we have the correct version. So we're setting the correct version. And here's where we're reading the very first thing. So we're setting the correct version to the version that we get. Okay, yeah, the correct version is here. There we are. So if what the version is that we've read from the file is less than the correct version, then we've got a problem. You've got old data. You've got the data from the introductory class, and we've changed our formats a little bit, so that's no longer compatible. So we'll throw. It's not a serious exception. We'll throw a regular exception. So the file version is not correct. It probably should be a serious error. It could be a regular. You might want to make it a regular exception, because the thing to do at this point now, the program that called the user object can say, oh, I've got a regular exception because the versions aren't right. So I'll just call this other procedure that converts the file from the old format to the new formats, and then starts over, and everything's fine. But the world doesn't work that way. They'll call you up and say, you need to send us more money because you got the wrong version. So yeah, we won't worry about that. So here's where we're catching the exception. If it's not there, we have a file not found, which is a serious exception because it should have been checked already. So the version is good. We'll read the rest of the columns. So we're back in another try block. So we're reading it. So each one of these is a field, and each field is an object. Each object has got its own methods for reading and writing and getting and setting and validating. So we'll read from the stream the user ID, the name, the address, city, and after that, the user has more than one account. We will keep reading the account as long as we don't have an end of file on that stream. So we'll get the account file name. It makes sure it's greater than 2, because you could have a new line, which get counted as a character, but then we don't have an account name of new line, so we'll just keep going past that. And we'll have my accounts, which is our vector of accounts, and we'll push back that new account with the file name that account is associated with, which is what we stored in the user file. So instead of storing all of the bank information, what we're storing for each bank account that the user has, we'll have a file name associated with that account. And so then we can open that file. Actually, we can stop and ask the user, which account do you want to work with? And so the user will say, well, I want this one. So then we'll go to that file and open up all of the transactions. We'll get the bank account information and the list of transactions associated with that account. And if we have any problems, we catch the exception. There's a serious exception reading from this file, because there are no acceptable exceptions, so kick it up one. So we'll throw a serious exception, and the caller will get the serious exception. And if they don't catch it, then it'll just keep, each exception will keep going up the chain until somebody catches it or the system crashes. Now we were at read. Oops. And we wanted to go to write next. Okay, here's where we're writing the file, which is real simple. We have each field is being written out to the stream. And I had the option between having the write any method open up its own stream, or have the stream ID passed to it. And I chose to do it this way in this particular instance, not for any particularly good reason. Sometimes you think, well, you may want to open up a different file and write to the different file, in which case you need the caller who has decided what file needs to be written to will pass to you a stream. But in this particular case, I probably didn't need to do that. I probably could have opened up the file stream internal to this method, but I didn't do it that way. It's nothing to worry about. So we have the user ID. Now each one of these is a field. Like I said, we're going to talk about that later. Each field has got its own methods. One of the methods is to override the output, the less than, the extraction operator, which takes the contents of the field and sends it to the output stream. And this way, the object itself is in control of what needs to be sent to the output stream. So each one gets put out. And then presumably at this point, we've got more than one account. So we'll read each guy in our vector. We're using iterators here. And the STD, because we're not using the namespaces, so we have to explicitly say it's a standard namespace vector for the accounts, and get its iterator. And so we've defined an IT as being an iterator for that type of vector. Set it to the beginning. My accounts begin until we get to the end. So while IT is not equal to the end, and increment the iterator to iterate from this one to the next one to the next one until we've got all of them. And At this point, it has been commented out because we were testing. So what you would have right here, what you really should have, is this to not be commented out. There we are. And then that will write this information to the file. And part of the writing that this particular field does, knowing that it is only to be written to data files, it writes the contents and then follows it by the delimiter. That allows you to read it back. You can read the field until you get to the delimiter. And you know, from there till you get to the delimiter, and not including the delimiter, you have the data to be placed into your field. Let's see if there's anything else interesting in here. Actually, we just go to the beginning and take a look that way. Let's go to the bottom. We're getting versions. And no, I think that's everything. And let me save that change. Let's do a listing again. What do we got here? Whoops. Okay. So let's look at the exception. Now, I don't have an exception CPP. I just did the header. Now, we have three severities of exceptions that we decided to write for them. We have a minor exception, such as the user has an input. He put a comma in his number and he's not supposed to. Well, that's just a minor exception. We have a regular exception. Something wrong has happened. We might be able to handle it and do something about it. And then there's a serious exception. It says, you got me, part. I'm dead. You know, we're going to just crash and burn, call the Coast Guard. We're done. Now, but they all arrive from the standard exception, so it's a class that can be caught. But now, see, here's another problem. You have to be careful to keep your comments up to date. Because I very distinctly remember not taking that away. So let's get rid of that. Let's delete the whole line and delete that, and let's save that. And the reason why I know that it's not doing that is because I have class exception, and it does not have a :public for the standard library exception. This is the exception that will be the type of exception for this particular application. And so we have the constructor, destructor, and like the standard library exception, there is a what that prints out something, and it prints out an unspecified exception, so that we just have an exception. We don't know what it is. Now, our minor exception now derives from the first exception. And we probably could have made, I probably very well could have made this a completely abstract class just by setting up something up here to say where this is equal to 0. But instead, I do have something that just says it returns a char star unspecified exception. Now, it's an option, it's a choice, it's a design decision which way you want to go. You have the minor exception, and there's a constructor, and what you would do is throw a minor exception. You would say throw minor exception, and then put a text in here. Why are we throwing this? Of course, another way of working this, you define an exception and have a completely different option that says, have an integer parameter that says how serious is this. I've seen some systems where they've got like 3 classes of parameters for each exception that can occur. There's how serious it is, a number that identifies the module because they've got hundreds of modules, and then the actual error code itself. So you have to look up the error code. So here's what the message, here's what it means, and then there's a particular module. So if you call them up with customer support, you give them the exact specifics of the error, the module number, they know which of their employees to contact and say, your module picked up this exception under these conditions, and we don't think that's correct. You need to go fix that code. It depends on what you're doing. This is a very simple class, so I just only got 3 exceptions. A 4th one if you consider the base class, which you probably shouldn't call. So this has an ouch factor added, which just says return the error minor. Now what's error minor? Error minor is 10. Error regular is 50. This is the severity of the particular error as a number. So you can catch the exception and you not know which exception it is. Just catch the base class and then test the ouch factor. For that matter, we probably should. That's a good idea right here. What we should have here is to have a virtual int ouch factor, which it would be better if I could spell with it. Constant. And you can throw nothing, and then set it equal to 0. And we do that. That means this is now an abstract class. It must be derived from to instantiate, and each class that derives from it must override the ouch factor to tell people, to tell the caller how serious this problem is. I might even try to compile this today. I haven't tried compiling on this machine before. It might not work, so no promises, but we'll see what happens. So we have the minor exception, regular exception, returns error regular. And the reason why I made them like 10, 50, and 90, so in case you need more fine-grained error handling, you can put something between 10 and the 50, that kind of stuff. Not particularly likely, but you never know. And then, of course, we have our serious exception. The next thing I want to take a look at here is the string field, which was not a good name because I kept spelling it Springfield, and then it wouldn't work. And I'd say, why isn't that working? I spelled that right. And I'd look at it, oh, no, I guess I didn't spell it right. So here we have string, not spring. So this is going to be a field in an object that has to be a string. And it has a few things which allows you to set it. Now, this is probably going a little bit overboard with the object-orientedness of the system, but I wanted to do something like this. In particular, what I wanted was to have it have a prompt method. So for a specific field, there's a couple of ways of getting the data in and out. One of the ways is to prompt the user. So you call the prompt method, you give it a string, and you print the string on the monitor. It says, please tell me the name. And then you stop and you wait for the user to type in the name. And I want to be able to read it from a file. And then here's my friend for overloading the operator for sending it to a stream, to an output stream. Now, one of the problems when you create a field like this as an object, there's all sorts of wonderful things now that you have to provide for that object. And here they are, all my operator overloads. I've got is this string field equal to this string field? Is it not equal? Is it less than or equal, greater than or equal? And you might say, phew, that's an awful lot. Well, it gets more, because now, oh, I got the wrong version. Let's do it now. We're just going to fix that right here. Because the other thing, you want to compare a string field to a string. So let's fix that. All right, now we've got 2 copies of everything. It'll crash, but that's okay. Because what we're going to do is go to other.field and change that. Oops. Yeah, that's right, 3CW field. Because now we're not comparing the field member of the object. We're comparing the object itself. Let's go to the next one. Change, next, change, next, change, next, change, next, change. Is that all of them? Yeah, that's all of them. But it's worse than that because okay. Because what we're comparing to is not a string field, but a string object. And not a string object, by the way. String. Here we are. This keyboard is not in a happy position. Oh, that's okay. There we are. Now you notice I actually do have the code, because the code for a comparison object is usually not very complicated, especially if you've only got one field that derives the comparison. If you have a complex object with many, many, many fields, and complex rules like, if this is true, then compare these fields. If that is true, then compare these other fields. That types of things can be very complicated. You may not want to keep it in the header file, and instead just put that into the CPP file, and so that it gets compiled separately, and then just include the headers with the each program that brings in the header. But in this case, since I only had a very simple case, I just left the definition in the header file. Now, to be complete, we should also change all of these so that if you see, this will compare this will compare a string field. Let's type that right. A string field object to a string object, like that. If you want to be complete, we also need to compare a string object to a string field object. Now, in order to do that, I'd have to copy all these all over again and make them friend functions. And the friend functions do have to get placed into the CPP file. But that's a complexity that I'm not going to put into the class right now, so we're not going to worry about that. Just keep that in mind. Anytime you're going to have your object compare to something else, your users are going to expect it to work the same way, so you need to write the code for both. But since this is a very simple project, we're not going to worry about it. We're going to save all that and exit. Now, the next thing we have is a number field. Oh, wait, let's look at the CPP first. So I have a maximum line for the string field of 512, which should be more than enough for the types of fields in this bank account application. So we have the field and we have a delimiter, and I thought about it later that delimiter should be in the global constants include file, but right now it's here. So we have the destructor, which doesn't really have to destroy anything. The setter that sets it to the field becomes a new val. Getter just returns the string text of the field. And here's the prompt I was telling you about. So we prompt, you call the prompt, you give it the message, and so basically what we have is the object itself. It's object, prompt the user, find out what he wants, and have him, whatever he types in there, store yourself to that. So we prompt the user with the message that was passed in, and then we get the input from the user. Now you can make this a little bit more complex with different things like, please say yes or no. And then test it at that point where the user says, if he puts in a yes, cool. If he puts in a no, cool. If he puts in anything else, you say, wait, I said yes or no. But I would not do that in this object. You might want to like derive it into an additional object instead of string field, call it yes or no string field. And in there, you can override the prompt method to put in your tests. And here we're reading from an iStream. Now, we could overload the operator, but I had a few problems with that, which I won't discuss. I couldn't get it to work. It's one of the difficult things to get working because you need friend operators. You need to be friend with the iStream, and then you have buffer issues. If you use getLine, like I have getLine up here, and if you use cin, you will have buffer issues because depending on the system, they might be in different buffers. It gets the same thing on cout. If you have some C code in there, you have a printf, because the printf defaults to go to the standard out. Cout defaults to go to the standard out, but they keep different buffers. So if you have some C code in printf and you have some C++ code, it has a cout. The cout, even though it's physically after the printf, the output might come out before, and everybody's scratching their head, what's going on? So for input and output, settle on one specific input method and stick with that. So here's our output operator that overloads, it goes to the output stream. Now I want to look at the number field. So what we did with the number field was inherited the string field. So basically the way we're implementing a number field is a number that has a string component, because that's the part that will be displayed for the user. That's the part that will be input from the user. We just have to parse it to make it into a number so that we can do arithmetic on it. Because you can't do arithmetic on strings. In this particular case, I decided to make it a double, and I gave it a tolerance, which I'll show you why that in a minute. So we have the constructor, destructor. We're overloading the set with a double, so we can set it with a double number, and we also can set it with a string, which will need to be parsed. There's our prompt, which we're overloading, because what we're going to do is call the string field prompt, and when we get the data back, we need to parse it and make it into a number. Same thing with read, and we want to get value where we don't have to worry about translating between numbers and strings. We just want to get the numeric double value, so we have get value, because it turns out we're adding the value as a double. And of course that means we have to overload some of these operators. Now, here's a comment which wrapped very badly, but I'm going to fix that so that you can read it. But all of this is in your downloads anyway, so you don't have to really worry about that too much. I'm going to see if this has an old Unix trick. And it does. Wait a second. All right. Now, when you're working with doubles, you have to remember it can be difficult for two double precision numbers to be matched. You'll see code like this broken all the time. They'll have a double precision number. They'll have a floating point precision number. They'll do all kinds of calculations. And we're going to keep doing this calculation until the result equals 0. Well, the result may never be equal to 0, but you might get close. You get to 0.001. 0.00001, 0.00001, but in the nature of numbers, instead of the next one becoming 0, the next one now becomes minus 0.00001. It's close enough, but it's not exact. This is a long recurring problem with floating point numbers in computers. And so what we've got, instead of having them be actually equal, we're calling the math precision floating point absolute value. We're taking the value minus the other value and seeing if they're close to each other within our tolerance. And when you're talking about pennies, we have 0.01. This is a very, very tight tolerance. So if you get so you should have seen that in your introductory class. And when you print out a floating point number, you're expecting to get 20.5. Instead, or you expect to get 20.1. Instead of getting 20.1, you get 20.9999998. And you scratch your head. Wait a minute, that's not how it's supposed to work. That's the way it works with floating point numbers in computers. So what if you have some code in there that says if value equals 20.1. It may never be equal because they just won't match. You have additional problems with promoting a floating point to a double. If you have a floating point 1.7, it is not equal to a double 1.7 because the float 1.7 will work out to be 1.699999999, and then the double precision will work out to be 1.7000001. And so they won't be equal to each other just because one's a float, one's a double, and they rounded differently. So it's just a problem to keep in mind that when you're comparing, that's what we're doing here, we're comparing two double point numbers, and then rather than calling that again in not equal, what we're doing is returning that it is not. Let me bring this down here so it's easier to see. we're calling the equality operator and doing negation of it. Now, since this is C++ and not C, we probably should have done it this way. That way it's a little bit easier to read, more human friendly. And C++ will let you do. Modern C++ compilers will take the not and the and other keywords. So that's this one, the CPP version. See this code. And here's the set. Now we're using a string stream to do our conversions for us. So we're taking the value of the string. Here we have a double. So we're basically keeping two copies of the number. We're keeping string version and we're keeping the numeric version. So here we're passing in a double as the new value. We're setting our local, internal member to that. And then we're defining an output string stream called sout. And then we're using the extraction operator. It's just like printing onto the screen. It will take the number and convert it to ASCII characters and put the ASCII characters on the screen. Only instead of going on the screen, it's going into our stream object, into our string object, our ostring object. And then the field, which is a string, gets a copy of the string version of the string stream. So this way, we don't have to go through a lot of heartburn trying to convert between numbers and floating point and strings and things like that. It's already a system that does that. And you can get worse than that. We can do things like we can use the I/O manipulators. We can set our precision to 2 because we're only going out to pennies. We might also want to make that fixed. So right away we've got, if somebody puts in 1.99999, this will automatically make it put in there 2.00. And that's what will get stored in our string is 2.00. And here's where we're setting the string and doing the exact reverse. We have an iString stream, which is being initialized to the string field, which was put in as a new value. And then we're using the input operator to get that loaded into our floating point value. And here's the prompt where we're calling our base class to actually do the prompt and get the information into the string. And then we're calling our own set to take that string. Since we've already written the code that converts it to a number, we'll just call that code, convert it to a number. Here we have the same thing with read. Get values, we just want to see what the numeric value is. Now we also have an integer field, which pretty much does the same thing. I thought about the possibility of making this into a template. Since basically the integer field and the number field basically do the same exact thing. The difference being the number field deals with floating point numbers. The integer field deals only with integers. So this would have been a very good candidate to make into a template. But I was thinking, well, there's only the two of them. So a template would really be much better if you've got issues where you've got more than 2 or 3 things to duplicate. But there is another advantage to that. If a change comes up, someone said, okay, you've got read, you've got prompt, you've got all these wonderful methods, but we need these additional methods. Well, now you've got to add them to both the number and to the integer. Possibly you also have to add them to the string field method and override it. All this. So as a template, your changes, you've got less work to do. So it's a very good idea to make that into a template. It just turns out I didn't. Oh, my favorite, the date. Oh my God, the dates are an absolute nightmare. No matter how you look at them, there's so much to be done in dates. So you've got the time T, you've got the issues where that's seconds from January 1st, 1970. There's a time structure that's there, which is different on different platforms. I tried to use only the basics that should be common to all platforms. So they've got a couple of constructors. There's just a default constructor. There's the integer for year, month, day. There's a copy constructor, and of course a destructor. A few methods for converting the time structure to seconds, and taking the time seconds and converting it to a GMT time structure or local time structure. And time zones is another nightmare. There's some areas that cover daylight savings times. There's some areas that don't cover daylight savings times. Here in the United States, we expect every time zone to be on the hour of every hour. Some parts of the world, the time zone's on the half hour. So if you want to have a complete world-savvy date system, you've got a lot of work cut out for you. You get the year and the month and the day. Here's our overloaded operators. The 2 days are equal to each other. And rather than writing overloading the output, we have just convert it to a string, and you can take that string and do whatever you want with it. Let's see the CPP real quick. A little bit of a comment there. There are some conflicts with handling conversions between local and GMT time because basically the specifications haven't been well thought out. I don't know if there's anything in particular here that we want to look at. Probably not. I mean, you get the second. We just pull it out of our time structure for most of the stuff. ToString is an issue with calling the strftime function, which is a C library function, and it doesn't handle C++ string objects, so you have to convert your string objects to character arrays. And when you do character arrays back and forth, you have to worry about memory allocations because you don't want to have memory leaks. So there's all kinds of issues involved. Yeah, let's get out of this one, move on to so it's another function. What else have we got here that we haven't looked at yet? We got the date field. Let's take a look at the bank account main. This is the main routine. Here's our isUnique function that has a set. This is just a test version. There is a version out here that uses a set. Oh, here's the set right there. So what this really should have in here. So I can put testing on the command line. I can put -D testing on the command line, and this will just always return true. We don't even need to make it the if, do we? We just return if it's true. If this returns, there we are. So if there is no file name in this set, then if that's equal to 0, then we'll return true. That means this is a unique file name. You go ahead and add it. And no, I know why I can't do it that way. We want to go ahead and add it so that the next time we ask, then we can return true. Otherwise, return false. Yeah. So if we put it on the command line that we're testing, we will just always return true. We can test that this file is always unique all the time. If we're not, you would do such other stuff. So we have our splash screen. Hello, welcome to Checks Beat Us, the world's greatest checking account program ever. But the one in the introductory class was the world's greatest checking account program. But this is new and improved. So here's where we start up the user. So we get a brand new user with our current version and the ini file that we're going to read, and we'll read all of our user information. But if it's not there, then we need to create a new user. But that is what our startup function will do. It will say, well, if this isn't there, we'll prompt, hey, you don't seem to have an ini file yet. Let me get some information from you, and we'll get all this information and produce it in the ini file. And if you don't have any accounts, which is something I was planning to put into the account object itself, but this is an early version, but there will be a much better version than in your downloads. Oops, I don't need to write that change. And I think that's just about everything else I wanted to show you. So we'll head back to this. And come to the end of our class and the end of our lessons. And so that's pretty much it for intermediate C++. Make sure you check the forum if you have any questions. Make sure you download the materials, do your homework. There is a lot more to be learned in C++, but I don't know if the class environment is the best place to learn. Probably the best place to learn it is to actually get out and work with it, learn it. Search the internet for C++ forums, and there's one really nice one called Stack Overflow. You have people asking all kinds of insane questions, but some of them are very good questions, and check it out and say, well, that's an interesting question. Let me see if I can answer that question. And that way you'll get to learn a lot of advanced, obscure features in C++. And actually get out there, just start cutting some code. But that's it for this lesson.